Hello all. Today we are going to see on the topic Floyd-Warshal algorithm. Floyd-Warshal algorithm or Floyd algorithm was introduced by Robert Floyd and Stephen Warshal in the year 1962. This algorithm is used to find the shortest path in an edge-weighted graph, which can be directed graph or an undirected graph. Let us consider an example. A butterfly has to collect nectar from different flowers which is positioned in different direction in a garden. We have to help the butterfly to find the shortest path between each pair of the flowers such that it can collect the nectar easily. Now the above example can be written in the form of an undirected edge-weighted graph where the vertices represents the flowers and the distance travelled by the butterfly from one flower to another flower can be represented as edges having edge weights respectively. Algorithm. Develop an n-cross-n matrix based on n vertex network given. The diagonal elements are empty. The ijth cell of the matrix is entered the value dij, denoting the distance between the vertex I and vertex j if there exists an edge between I and j vertices. If there is no edge joining between I and j vertices, then dij will be equal to infinity. Now, in our case, it's an undirected edge-weighted graph, meaning that we can go from vertex 1 to vertex 2 with the edge weight 5 and vertex 2 to vertex 1 with the edge weight 5 again. We can go from vertex 2 to vertex 3 and vertex 3 to vertex 2 with the edge weight 6. So, let us see how to fill the matrix. Now, in our case, it was 5 cross 5 matrix. That is, we have n 5. That is, we have 5 vertices. We are going to fill the D matrix and the S matrix, where D matrix represents the distance matrix and S matrix represents the vertex sequence matrix. D naught and S naught represents that we are in the initial stage. That is, K is equal to 0. Now, the asset in the algorithm, the diagonal entries for both the matrix will be kept empty and the other values are filled accordingly as said in the algorithm that we have. If we have a direct edge between two vertices, then the edge weight will be written in the matrix. That is, from 1 to 2 we have the edge weight 5. So from 1 to 2 edge weight is 5 and 1 to 3 the edge weight is 1. 1 to 4. 1 to 4 there is no direct edge. So in that place we are going to write infinity. 1 to 5 there is a direct edge, that is 2. Similarly, we are going to fill this D matrix, that is 2 to 1. 2 to 1 there is an edge weight of 5, 2 to 3, 6, 2 to 4, 4 and 2 to 5 there is no direct edge. So we are going to put infinity in that place. Now 3 to 1. 3 to 1 the edge weight is 1, 3 to 2, 6, 3 to 4 it is 7 and 3 to 5 it is 2. So similarly it is filled in the third row and 4 to 1 there is no direct edge. So we have put infinity. 4 to 2 it is 4, 4 to 3 it is 7 and 4 to 8, 4 to 5 it is 8. Similarly 5 to 2. 5 to 1 it is 2 and 5 to 2 there is no direct edge. So that is infinity. 5 to 3 it is 2, 5 to 4 it is 8 and 5 to 5 there is empty. So this is how we fill the distance matrix and let us see how to fill the vertex sequence matrix. The vertex sequence matrix is filled in this form, that is each column will be filled with the number 1. First column will be filled with the number 1, second column with 2, third column with 3, fourth column with 4 and fifth column with 5 except the diagonal entries. Now we are going to look into the next iteration, that is iteration k is equal to 1. Before going to that we have to follow this condition, that is dik plus dkj is less than dij, where all I, j and k will be different. Now let us go to iteration 1, that is k is equal to 1. Initially we are going to fill the D1 matrix and the S1 matrix with the help of the D0 and S0 matrices. So in iteration 1, the first row and the first column is kept same in the D1 matrix. That is the first row and the first column will be same from D0 matrix to D1 matrix, it will be same. So this row and the column is denoted as the pivot row and the pivot column. The other entries from D0 matrix is filled accordingly by using this condition. So the next entry to be filled is this cell, that is D23. D23 implies that I is equal to 2 and J is equal to 3 and K is 1 here. So applying this condition here, that is D21 plus D13 is less than D23, which implies that this cell and this cell, adding this and this, that is 5 plus 1, should be less than the entry which we are checking, that is 6. So 5 plus 1 is less than 6. So there is no change. We will write it the same number 6 in the D1 matrix. Next, 5 plus infinity is infinity, which is greater than this number 4. So we won't change anything. 4 is written like that. The same in the D1 matrix. 5 plus 2 is 7, which is less than infinity. So we are going to change 7 in the D1 matrix. Simultaneously, we are going to change the numbers in the vertex sequence matrix. That is, wherever there is a change, there we are going to put the number, that is iteration number. We will replace the 5 with the iteration number. Which iteration number, in which iteration we are, that is k is equal to 1. So we are replacing 1 here. The remaining numbers will be same from the D0 matrices. Okay, next for 3. For 3 we are going to check this third row, that is we should check this cell, the corresponding pivot column and the pivot row, add it and check whether this number is less than the cell entry. That is 5 plus 1 is 6, less than 6. So 6 is written in the same form. Diagonal entries is not checked. Then 1 plus infinity gives infinity, which is greater than 7. So there is no change. 7 is written. Then 1 plus 2, it is 3, which is greater than 2. So 2 is written. So in the S0 S1 matrix, the same entries will be from D0 to D1. Next, fourth row, how we are going to fill, that is infinity plus 5. We get infinity, which is greater than 4. So 4 is written as it is. Next, infinity plus 1. We get that is greater than 7. So the 7 is the shortest. Next, infinity plus infinity. Oh, this is not there. Infinity plus 2. We get infinity and 8 is less than that. So 8 we are keeping it like that in the D1 matrix. It's same. Next, infinity. Here infinity we should change. We should check whether we have a lesser number here. So check the corresponding column and the row in the pivot column and row, that is 5 plus 2 we get 7. So 7 is less than infinity. So we are going to replace infinity by 7. So simultaneously in the sequence matrix we will put 1. That is the iteration number. Next 2, that is 2 plus infinity. 2 plus 1 is 3. 2 is less than 3. So 2 is written in the same form. Next 8. 2 plus infinity is infinity and this 8 is less than infinity. So 8 is written. Only wherever there is a change in the place in the D1 matrix, we are going to change the S1 matrix with the iteration number we are in. That is, we are in k is equal to first iteration. In a similar way, we are going to fill the other matrices with the help of the previous matrix we have constructed. Iteration 2, that is k is equal to 2. Now let us see how to fill the D2 and the S2 matrices. So in the previous matrix, that is D1 and S1 matrix, we mark the second row and the second column as the pivot row and the pivot column. So that row and column will be the same in the D2 matrix and S2 matrix. So the remaining elements are filled in this manner. That is, check this number 1. So corresponding pivot column and pivot row elements is checked and check for the condition, and the entries are filled. That is 5 plus 6 is 11, which is greater than 1. So 1 is written. Then we have infinity, that is 5 plus 4, we get 9. So 9 is less than infinity. So we are replacing infinity by 9, and 5 plus 7 is 12, which is greater than 2. So there's no change, that is 2 is written as it is. Since we have the infinity is changed to the number 9, the vertex sequence matrix changes from 4 to 2, that is the iteration values takes its place. Next 1. So 5 plus 6 is greater than 1. So 1 is written in the same form. Next we have 7. 6 plus 4 is 10. So that will be greater than 7. So 7 is written as it is. Next 6 plus 7 gives 13, which is greater than 2. So 2 is written as it is. And the vertex sequence matrix, it follows the S1 matrix. It will be same. Next, here infinity is to be changed, and we will check whether we can change this. So infinity 5 plus 4, it is 9, which is less than infinity. So we are going to change this infinity to 9. Simultaneously we are going to change in the vertex sequence matrix with the iteration number, that is k is equal to 2. Then here 7. For 7, 6 plus 4, that is 10, which is greater than 7. So there is no change. And 6 plus 7, that is 11, which is greater than 8. So there is no change. We are writing as it is. So in this manner, we are going to fill the last row elements. That is, for 2, it is 7 plus 5, it's 12. 7 plus 5, it's 12, which is greater than 2. So it's 2 is written in the as it is. Then 7 plus 6, it's 13, which is greater than 2. So there's no change. And 7 plus 4, it's 11. It is greater than 8. So there will be no change. The only changes are in the fourth row and the first row. Simultaneously, the S2 matrix is changed. Now, iteration 3, we are considering the third row and third column to be the pivot row and the pivot column, and those entries will be the same in the D3 and S3 matrices. And we have checked the condition and found that this 9 is less than. So let us check this 9. So 1 plus 7, that is 8. It's less than 9. So we are going to replace these values. That is, we have got the changes in this fourth column first element and fourth row first element. Similarly, we are going to change the vertex sequence matrix and substitute the iteration value in the S3 matrix. So in iteration 4, we have considered the fourth column and the fourth row to be the pivot row and the pivot column in the D4 matrix. So these entries will be same, and we are checking whether we get any least value. All the infinities have been replaced to the numbers. So that will be the end of the algorithm, and but also we will check if we have got any lesser number than those things. So while checking, we got a D3 and D4 matrix to be the same. If we get the two matrices same, the algorithm stops. There is no change in the D4 matrix. It is same as the D3 matrix. So here our algorithm stops. So which indicates that we have found all the shortest paths between the vertices. Now, to find the distance between each pair of the vertices, we look into the distance matrix. The path which gives the shortest route is determined from the sequence matrix. Now, let us take an example. Let us find the shortest path from vertex 1 to vertex 4. So from vertex 1 to vertex 4, the shortest path is infinity. Initially, we saw that there was no direct edge from vertex 1 to vertex 4. So we had written infinity. That infinity is changed to the shortest number, that is 8, shortest distance. So in the similar way, we can find the shortest distance from each vertices to other vertices. So from 1 to 2 it is 5, 1 to 3 it is 1, 1 to 4 it is 8 and 1 to 5 it is 2. So 2 to 1 is 5, 2 to 3 will be 6, 2 to 4 will be 4 and 2 to 5 will be 7. So these will be the shortest paths. Now, shortest distance. So we'll see how to find the shortest path, which is the through which way the shortest path is attained. So from 1 to 4, we got the shortest distance to be 8. We will see through which path we are attaining 8. So that is used by the condition Sij is equal to j. Sij indicates that from which vertex to which vertex we are going. That is, we want from 1 to 4. So S1 to 4 should be 4. So we'll check if it is 4. So S1 to 4, it is 3 and it is not 4. So this is not matching with this condition. So we will check which number we have got 1 to 4. That from 1 to 4 we got 3, which indicates that there is an intermediate vertices. So we will check from 3 to 4. So from vertex 3 to 4 we have 4, which matches with this condition, that is S3 4 will be 4. So the path is from 1 to 2, from 1 to 3 and 3 to 4 we attain the shortest path. See, from 1 to 3 and 3 to 4, that is 1 plus 7 8. So this will be the path, shortest path for the vertices 1 and 4. We'll consider another example, that is the shortest distance vertex from 2 to 5. So from 2 to 5 it is 7. We'll see through which path, that is we will check in the vertex sequence matrix from 2 to 5. So S2 to 5 we should get 5, but we have 1, which indicates that 1 is the intermediate vertices. So we will check S1 to 5. S1 to 5 is 5. So it matches with this condition. So the path is from 2 to 1 and 1 to 2. So the path is from 2 to 1 and 1 to 2, we will get the shortest path, that is 5 plus 2, 7. So, when compared to any other algorithm to find the shortest path, the Floyd-Warshal algorithm is much effective, since at the single execution of the algorithm, we will be able to find the shortest distance between all pair of vertices. So, that is all about Floyd-Warshal algorithm. Thank you.